Hey guys, let's go over lesson 2.1 now. We're in chapter 2 here. And our learning targets are after this lesson. You should be able to do learning target number 1, distinguish the difference between explanatory and response variables for categorical data. So categorical. Remember, your answer is yes or no. They're just words. Learning target number 2, we're going to make these segmented bar charts, or just basically stacked bar graphs. Between two categorical variables. So we're not crunching any numbers, we're just kind of organizing the data. And learning target number 3, determine if there's any association. That's the big word right there, association. All right, learning target number 1, relationships between two categorical variables. First step in describing relationships between two categorical variables is to determine which variable is the response. This one is the response variable. And the other one, which was called the explanatory. They're both variables, and those are abbreviated by EV, and let's use a different color over here, RV. So an explanatory variable, EV, nope, I wanted to use orange. An explanatory variable may help predict or explain changes in a response variable. We want to know, does it explain what's happening? The response variable, the RV, measures an outcome of a study. All right, so how do I remember this? An explanatory variable an EV explains. So hopefully you saw the EX there. Okay, so a response variable, whoops, and that one that goes in there, it actually represents the x-coordinate. So your old friends, the x's and y's. Okay, the response variable is the y-coordinate. And it helps give you the results. So if response results. All right, so let's go down here. Does the x affect? Color have we not used? The y. Does the x affect the y? Now, we have to be careful. There's a word that we cannot use right now. Do not use the word cause. All right, let's do an example down here. Identifying the explanatory variable for the following relationships. Explain your reasoning. All right. So let's find the one that explains what's happening. 1A, class in a school, the freshmen, sophomore, juniors, seniors, and whether or not the student is allowed to stay up past 11 p.m. or school night. Okay, we're trying to find the one that explains, not the results, if you can stay up or not. So in this case, the class in school. So if you're like, say, a freshman, maybe you just got into high school and your parents are not willing to stay out. But if you're a senior, maybe you could just be home by 11. Would be the explanatory variable because, so my explain word, because of maturity may influence your curfew time. Right? If you're mature, maybe if you might be a mature freshman, but usually it's the juniors and seniors a little bit more mature, right? They're the explanatory, and the results, the response variable is whether you can stay out or not. Okay, let's try this next one. The political viewpoint, conservative, liberal, or moderate, and a gender for the adults over 25 years old in the United States. So what's going to help you pick one of these? Well, your response might be these, right? Let's call that RV. But what explains that is your gender. So let's write that. Gender may help explain one's political viewpoint. All right, why don't you press pause and go ahead and try these 3 examples there. Example number 2, 2A, 2B, and 2C. This one, you need, for each question, identify which is the explanatory variable, the EV, and which one is the RV. It's supposed to be blue. Go ahead and press pause, and then we'll do these together. All right, so you have some time to complete example number 2, time spent practicing guitar. I think that explains, right? This is the explanatory variable because if I spend time, it explains if people like my music or not. If number of faces are melted by my awesome musical abilities, okay? So that's the response, okay? All right, GPA and ACT or SAT score. So if you have a high GPA, that explains why you do so well on the standardized tests. Maybe you learned in school, right? You're studious, you got good grades, and that response variable means you get a high responses, you get a high SAT or SAT score. But it can also happen where maybe you're just a good test taker and that helps you get good grades in school. So the answer for this one is both. It can go either way. Either way. And 2C, cheerfulness in the morning and hours of sleep. Well, if you are very joyful in the morning, does that explain how many hours of sleep you got? Well, the explanatory, if you get lots of sleep, this explains how cheerful you are in the morning. So that would be my RV, okay? So that's page 1 of our notes. Let's move on to page 2. All right, so we just did learning target number 1 on page 1, explanatory and response variables. Now we're going to do learning target number 2. So this deals with our relationship between 2 categorical variables. So after identifying the EV, it's not working, and the next step is displaying the distribution on the graph for each category of the explanatory variable. This can be done with, we like to use something that can be done with a side-by-side bar graph, bar charts. Because remember, that was a categorical graph back in chapter 1. Or they call these segmented bar charts. What's a segmented bar chart? A segmented bar chart, also called stacked. So here in blue, pink, and orange, the last ones I just wrote, they're all synonymous. They're all the same. Stacked bar charts displays the possible values of a categorical variable as segments of a rectangle with the area of each segment proportional to the percent of individuals in the corresponding category. What does that mean? So look at here on the left side. This one is called a side-by-side bar charts. And I basically have two bar charts next to each other, females and males, and they're measuring superpowers, right? And maybe they send out a survey and saying, which superpower would you like, right? And maybe you can only pick 2 or 3, and this is the responses, right? Okay, now, it's kind of hard sometimes to compare those. Now, you can compare them side by side, that is helpful, right? Invisibility, super strength, telepathy, flying, or freeze time. But, let's see if I can do this. If you take invisibility, this orange one was for females, and invisibility is this one right here. And what we're doing is we're just stacking them. Super strength down here. And then telepathy. Oh, I mixed them up. That's telepathy. This one was invisibility. And then this next one is flying. The colors don't match up there. And freeze time. That one's a little bit hard to see. And then on this side, the males, invisibility. And then super strength. And I guess you get the idea is we're just stacking them. Kind of looks like a parallel box plot. But remember, those are with quantitative data. And then our freeze time. Okay? So basically we're going from this side over to this side. So how do you make a segmented bar chart? Well, the first thing you're going to have to do is identify the variables. Whoops, I always do that. Identify the variables. Determine which variable is the explanatory variable and which is the response variable. Number 2, draw and label the axes. I'm not writing here. Axes. There you go. Put the name of the explanatory variable under the horizontal axis. Remember why? Explanatory explains, and you think of it as the x-axis, right? So lots of x's there. X, x. To the left of the vertical axis, indicate if the graph shows the percent. So on the y-axis, you're always going to have the percent here, or the response, the response variable. Number 3, make sure to scale the axes. Write the names of the categories of the explanatory variable under the horizontal or the x-axis. On the vertical axis, start with 0% or 0 and place the tick marks at equal intervals until you reach 100% or 1. Number 4, draw your 100% bars above each of the category names for the explanatory variable on the horizontal axis and make the bar bars equal in width and leave gaps between them. Number 5, make sure you segment. That's like, going from here, taking the little rectangles and stacking them. Calculate, so we're going to have to do, for each category of the explanatory variable, calculate the relative frequency for each category of the response variable, and then divide it by the corresponding bar so that the area of each segment corresponds to the proportion of individuals in the category of the response variable. So I'm just going to highlight 2 words here, relative frequency. Get a percent. And then number 6, include a key that identifies the different categories of the response variable. That was page 2. All right, here we go, guys. Page 3. Which gender is more likely to have allergies? So, data on gender or whether or not a person had allergies were obtained from a random sample of 227 students who responded to a survey on the census at a school website. So here we have a table. I just want to point out that this, can I not write? Hello. This is one category. Why? Do you have allergies? Yes or no? What's our second category? Well, our second category is gender. What's your answers for gender? You're either male or female or male. Make a segmented bar graph for each of these, okay? So, if you go back, step number 1, we need to explain which one is our explanatory. So, remember this is the x-axis and that's the y-axis. That might be super helpful for you. And our explanatory variable is up here. Our explanatory variable is gender. The gender might tell us about allergies. Allergies will not tell us about or explain to us about gender. Okay, so I'm going to write down here female and male. Okay, so step number 1. Number 2, we're going to draw and label the axes. So that's what I'm doing right now. And then over here is going to be our percent. 0, 20, 40, 60, 80, and 100. Okay. And we have a scale, which I just did. Okay, now we're going to draw our 100% bars. Number equal width. All right, this next part is going to probably take us a little bit of time. We need to segment these bars, and we have to find the relative frequency for this. How do you do that? Well, so females, there's 50 females that said yes, they have allergies, and 80 said no. So if you add those together, you get 130. Okay, so how do you find a proportion? Well, essentially what you do is you just do 50 divided by the total, 130. You put in your calculator, you get a decimal, and then multiply by 100, and you get approximately 37%. Same thing over here, 80 divided by 130, and you will get approximately 63%. Okay? Let's do this now for males. And again, if you notice which direction I'm going here, I am going down. For males, I'm going to do the same thing, right? 34 plus 63 is 97. So 97 is my total, and it tells you there on the far left side. So now I'm going to do 34 divided by 97. If you put that in your calculator, remember you get a fraction to a decimal, and you multiply that decimal times 100, and that gives you the percent. Sorry, that's totally pixelated. Zoomed in too much. So 34 divided by 97 and then multiplied by 100 gives me 35%. And 63 divided by 97, put that in your calculator, then multiply by 100, and you get approximately 65%. Now, I do want to point out something really quickly, is that when you add those numbers together, you will get close to 100%. Why is it not 100%? Because we do something called a rounding error, they call it. So it is approximately, you might have like 100.1, you might have like 99.9. It's just because of how you're rounding, okay? All right, so let's go over here. And so let's make our segments now. Let's use, so I'm going to do the 37. Let's make a key here. This is yes, has allergies. No, allergies. Okay, so females have 37% allergies, something like that. And males, if you look at our chart here, has 35% yes, has allergies. Okay, now females have 63%, which is basically just the other side of the bar. Does that make sense? Because it adds up to 100. Oh, it's like Joker colors. And this side over here. Males was 65%, which is the rest. All right, so there is something called a segmented bar chart or a stacked bar chart. All right, let's go on to another big idea and we'll bring them all together. So once we make a graph, the final step is to determine if there's an association between the two categorical variables. Definition: there is an association between the two variables if knowing the value of one variable helps us predict the value of the other. If knowing the value of one variable does not help us predict the value of the other, then there is no association. Okay. So basically, it all comes down to size of the segment. Size of segment. Let's do the superpowers problem again. Example number 4, the superpowers and gender. Is gender associated with a certain superpower? What do you guys think? So we can see, as I said, it's just about the size of the segment. So we can see the association in the segmented bar chart because the segments for each superpowers are not the same what? What's the big word here? Size. for the female and male graphs. Okay, so let's compare a couple. So question, is there association? The answer is yes. There appears to be an association between gender and superpower preferences because knowing a person's gender helps us predict which superpower he or she would prefer. Okay? All right, so look at the males. The right one. Which one is bigger in terms of, say, you could just do it by colors if you wanted to, really, right? The blue one. Which one's bigger? Well, the right side is, and that corresponds to males. So males are associated with what? Freeze time. So look at the size of their segment. Any others that can kind of be, I think here, comparing these two, that would be super strength. So that was green for males. Let's do, while females are associated with, so let's look at females. Which ones are they bigger with? Now, remember, this one looks higher, but it definitely looks bigger than this one. So females for flying. Telepathy. All right, that was page 3. All right, last page, page 4. Example number 5. Is there an association between allergies and gender? Use the graph in example 3 to determine if there is an association between gender and whether or not a person has allergies. So, go back to this one we just created here. And then think about what we just talked about in association. Once you try that problem, press pause and then press play when you're ready. Okay, here's a question. Is the males, no allergies, the green, bigger than the females? You're just looking at the size of their segments, basically. Well, this segment looks pretty much the same. And you can look back up there, right? We're looking at green, which is the nose. So here, and you look at those numbers, 63 and 65, it's pretty much the same, right? And then how about if you went down here and looked at, that was the nose, this is the yeses. Compare the males and females, the pinks. Let me highlight that for you. You can see it by just looking at the rectangle, or you can look at, I'm going to do pink, look at the numbers here, right? 37 and 35. So those numbers are pretty close, so we can say there's no association. Let's write that. Why do I always do that? Since the distribution, that is our new graph, the stacked bar chart of allergies is roughly, so remember in statistics we're never using like absolute words. You're always using like approximately, close to. The same between genders. There doesn't appear there doesn't appear to be an association. I'm going to capitalize that. It's kind of like our big word for today, for learning target number 3, between what are our two categories, between one's gender and the likelihood of allergies. All right, So example number 6, I'll go over it, but I want you to try it. But basically what I have here is I have 3 categories, kind of like which political party you are, Democrat, Republican, or Independent, or other. And then there you have it stacked bar graph there. And I want you guys to answer those questions below. So again, there's your first category, and this is your second category. Read it, try it, and then press play. All right, example 6 says, raising taxes on the rich or the poor. The stacked bar graph below shows a relationship between political party affiliation, so that's up here in orange, right? And views on whether it's better to raise taxes on the rich, over here in blue, or on the poor, for a randomly sample of registered voters taken nationally in 2015. Based on this sample, which political party identification, so they're talking about the orange, right, had the highest percentage supported by raising taxes on the rich. So when we say highest, so let me, the highest percentage of raising taxes on the rich. So that would be this one. And which one is more closely associated with that? Well, I think the biggest one is this one. And so all the top graphs, if you think about it, let's just try to highlight it for you, see if that helps. The raising taxes on the rich is everything above my white line. Okay, the middle ones are probably like they have no decision, they haven't really voted, and then the bottom, let me highlight that. The blue ones here represent raising taxes on the poor, and they're not sure. So the biggest one's going to be the Democrats are the highest. Remember this rectangle right here. Okay, which one had the lowest for raising taxes on the rich? Okay, I think this rectangle is smaller than the independent, just by a little bit. So I'm gonna write Republicans are the lowest. Again, all it is about is just the size of the bar chart almost. 6C, multiple choice. Which percentage of Democrats in this sample supported raising taxes on the rich? So I've got Democrats and raising taxes on the rich. So Democrats and raising taxes on the rich is again this rectangle here. So the question is, what percent is it? Well, remember these bars, each of these bars, this whole bar here represents 100%. So if we cut it in half, the whole thing, I think that's more than 50. So more than 50. Is it between 50 and 75 or over 75%? So if you take half of that again, this would be 50, 25, and yeah, I definitely think it's more than 75. So this is our correct answer. Okay. So again, this whole thing is more than 75%. Okay, it's just an estimate. All right, 60. In this sample, which of the following groups contains the greatest number of subjects? Okay, so when they say the following, in which this whole thing, which of the following groups contains the greatest number of subjects? So which of those, I don't know how to say it, which of those rectangles is the biggest? Which of the rectangles is the biggest? Well, we keep going back to this one rectangle, right? It's the biggest one. So this represents the Democrats who want to raise taxes on the rich, okay? And then if you had to pick one who was the smallest, that would be the Democrats. If you needed to, would probably be this one down here. Democrats who support to raise taxes on the poor and they're not sure. Okay, so the last one would be this one. So that's our lesson. The big idea from this 2.1 lesson is to be able to figure out which one is the explanatory or the response variables, creating a segmented bar chart, and then figuring out if there's any association, just looking at the size of those segmented bars. See you guys.